Sections D and E, we're going to be looking at adding, subtracting, and multiplication of radicals. So here in example 1, we're going to be talking about adding and subtracting radicals. The thing with radicals is we want to try and avoid that we can only add and subtract radicals if they're like radicals. For instance, square root of 3, square root of 3. Okay, if we have 2 of something plus 4 of something, or lots of something, notice that we can think of that as 6 lots of something, okay, and we can get that as 6 square roots of 3. The same way as we would maybe think of it as 2x plus 4x is 6x. So in example 1, we first have to identify that yes, we do have the same radicals. Then we know we can add them. So then we have 3 of something plus 4 of something. We are going to get 7 square roots of 2. Okay? In part B, we're going to look and say, this is square root of 3, square root of 3. They're the same, so I can combine them. If I have 5 of something, I subtract 6. I'm going to have negative 1 square roots of 3, or you can just write that as negative square roots of 3. Note, if you have something like square root of 2 plus square root of 3, you may not add them. This would be as simplified as it can get because they do not have the same base in the radicals. We cannot add them. Okay. Example 2. For simplifying here, so again, I'm going to look for things with like bases. So 5, 5. So I have 4 minus 1 radical 5. So I'm going to have 3 radical 5, combining this one and that one. And then I'm going to look at things with base 7. Okay, so I have 3 plus 5 of something, and I get 8 square roots of 7. Okay, I have square root of 5, square root of 7. I can't, they're different bases, so I can't add them. So we're just going to leave that. And it's simplified form. That does it for example 2. So example 3 here. Now we're going to look at multiplication involving radicals. So just like we are doing with other quantities, we have to make sure that here for multiplying 2, we're going to distribute to both our terms. So 2 times 2 is 4. 2 times square roots of 3, we're going to get 2 square roots of 3. Okay, and that's simplified. In part B, just like we did when we had a integer, we're going to multiply through with our surd. Okay, so we're going to get 5 square roots of 2 from the first one. And from the second one, okay, I'm going to get negative 2. And again, remember multiplication, I'm going to multiply my constants term together. So this has an imaginary 1, so 1 times negative 2 is negative 2. Square root of 2 times the square root of 2 is square root of 2 squared. Okay, well that's going to cancel out, so I'm going to get 5 square roots of 2 minus 2 times 2, because a square of a square root will cancel them out. And then negative 2 times 2, I'm going to get 5 square roots of 2 minus 4. And that's my final answer there. Okay, in example 4, we're going to expand and simplify. Make sure this is just making note of our negative, that negative is getting multiplied through to both terms as well. So we're negative square roots of 3 times 2 is going to be negative 2 square roots of 3. Always writing my coefficient first. Now negative square root of 3 times a positive square root of 3, I'm going to get a negative square root of 3 squared. Okay, those will cancel out, so I need to simplify. So negative 2 square roots of 3 minus 3. Okay. In part B here, as I distribute this through, again, making sure I know I'm dealing with that negative square root of 2, multiplying it through. I'm going to get negative square root of 2 squared. Okay, and then a negative times a negative is going to be positive, and I multiply my square roots together, and that's going to be square root of 2 times 3 is 6. Okay, well, the square of a square root cancels out, so I have a negative 2 plus square root of 6. And that's as expanded and simplified as I can get. Okay, so let's look at another example. Example 5 here. So notice we have binomial terms. Okay, so we have a this plus plus. So that just tells me I got to double distribute here. So in green, I'm going to distribute the 2 across. So 2 times 3 is 6. 2 times the square root of 2 is just going to be plus 2 square roots of 2. Now, in blue, I'm going to distribute the square root of 2 to 3. So I get plus 3 square roots of 2. And square root of 2 times the square root of 2 is going to be plus square root of 2 squared. Collecting my like terms, okay, I'm going to recognize that as I simplify this, I'm going to get 6 plus, well, this is a square root of 2, and this is a square root of 2, so I can add them. I have 2 plus 3 is 5 square roots of 2. Okay, this square cancels out the square root, so I get plus 2 there. But notice I still have 2 integers, so I can combine those. 6 plus 2 is 8, and I get plus 5 square roots of 2. And that is simplified. In part B, do the similar idea. I'm going to do green first. So 3 times 1 is 3. 3 times negative square roots of 5 is minus 3 square root of 5. Okay. And then now I'm going to distribute the plus square root of 5. So times 1 is just going to be plus square root of 5. And square root of 5 times the negative square root of 5 is negative square root of 5 squared. As you get better with these, you'll just stop doing this and you'll just put minus 5 there. You don't have to do the square root in the square in that piece. But as we're getting good with our skills, we want to maybe just be thorough here in the note-taking process. But hopefully as we get better with those, we can just see that right away. So as I simplify this, I have square roots of 5, and I have 3. So I have a 3, and I have a negative 3 square root of 5 plus 1 square root of 5, so that's going to be minus 2 square root of 5. Okay, and then minus 5 again. And just like before, I want to simplify my integers. 3 minus 5 is negative 2 minus 2 square root of 5. Okay, and that's as simplified as I'm going to get there. In example 6, expanding. Just like we are expanding other binomials, we want to make sure that we don't just try and square each term, but we're going to multiply it through. So we have square root of 2 plus 3 times the square root of 2 plus 3. So I'm going to make sure things get distributed out. Square root of 2 times the square root of 2 is just going to be 2. So I'm going to take that shortcut. I'm noticing that pattern. Square root of 2 times 3, I'm going to get plus 3 square roots of 2. And then I'm going to go ahead and do 3 times the square root of 2, get plus 3 square roots of 2. And 3 times 3 is 9. Simplify my integers, and I have 9 and 2, and that's 11. I have plus 3 square roots of 2, so I have plus 6 square roots of 2. Okay. And for our last example 7 here, we're going to expand and simplify. What we should kind of note here, and this is going to come up again in next lesson, is notice that we have something that we saw with difference of squares. We have a term plus a term. This same term that was here is repeated here, but now we have a minus, and the same term that was here is now being repeated there. So we should notice that those middle terms are going to drop out. So let's go ahead and execute this. Okay, so here I'm going to do 2 times the square root of 2 times 2 times the square root of 2. So I multiply my integers first, so I get 4, and square root of 2 times the square root of 2 is just going to be 2 because it's squared. Okay, and then I'm going to multiply this through, and I'm going to get minus 6 square roots of 2. Okay, now that's the first term. So now with another term, I'm going to multiply this 3 through. So I multiply this 3 through, and I'm going to get plus 6 square roots of 2. Okay, and this 3 to this, I'm going to get minus 9. So as I had predicted, notice these two terms are going to drop out as we saw with difference of squares. They should be opposite of each other. So then what we have left is we have 8 minus 9, which is equal to negative 1. Okay. So notice this final answer here does not have any radicals left in it. And that principle is going to be very useful when we multiply these together when we're talking about conjugate pairs and dividing by radicals. That concludes the notes for tonight. Go ahead and highlight any questions and make sure you bring your questions to our next class.